we're picking up in 3.7 where we left off. Just real quick summary of what we talked about Friday, if you guys remember, just as a brief recall. Okay, the front side of the notes, we talked about functions being either even or odd or neither. Even, remember, is one of two things. They were symmetric about the y-axis, or they had this algebraic relationship that f of x equals f of negative x. Odd, it was symmetric about the origin, and we talked about what that meant, or the algebraic relationship f of negative x equals negative f of x. Okay, neither was neither. Okay, we looked at some graphs. We decided if they were symmetric across the y-axis or if they were symmetric about the origin. Okay, and then we learned how to do the algebra part, right? Finding, let's see, f of negative x means putting negative x in place of x and seeing if that's equal, or finding negative f of x, which just means multiplying everything by negative. Again, figuring out which piece it represented. Now, in your class, we started into the backside. And if you recall, I said those green papers from topic 1, these tables are still around, right? Or I said the blue papers from topic 2, those still work too. And in fact, I think I will put one back up here. I have extras if you need another one. So we are, in this lesson, we are focused with the cubic and quartic graphs, x to the third and x to the fourth. And we just went through right here and used our descriptors, right? We put it in words we described. Now, the one thing, remember, I did ask that you do, state what do I want to say, what function it is we are doing these things to. So x to the fourth. And we talked about the different pieces here. This was x to the third. We talked about what all went on. This was another x to the third. Okay? So those are the two basic, well, I guess I want to say parent functions that we're using in this lesson. Now, you can see down at the bottom of this picture, and I have them right here, pictures, okay? Cubic function, y equals x to the cube. This is a good one to know. Okay, it's one your brain, it's one of those like x squared. X squared, I say x squared, and I expect you to visualize a parabola, right? So x to the third. I say x to the third, I'd like you to get to where you visualize. It's this curvy thing. A basic x to the third does go through 0, 0. It also goes through 1, 1, and negative 1, negative 1. Your next set of points, if you did the math, it would go through 2, 8, and negative 2, negative 8. But those aren't showing on that little snippet I put on there. Okay, so just kind of get that in your head. That's what an x to the third graph looks like. The other graph you'll be looking at, quite different, is x to the fourth. Now, x to the fourth looks a lot like x to the second, doesn't it? Okay, it's very much a similar shape. It's just, it's a little flatter at the bottom, and it goes up a little quicker. And in fact, just because I want you guys to have a little bit of a visual, okay, so there's a little bit of a visual, guys. The blue is your parabola, x squared. The red is the x to the fourth, the quartic. So, you know, they're very similar. They're just a little bit different, okay? So just to get a little bit of an idea there. Well, what did I do? So I did something wrong. Oh, well. There we go. No, I don't like that view as well. Okay, still, you get the idea. Goodness. Let's make a mess up here. Okay, so get these locked in your brains, okay? And I guess I will say here, x to the fourth, keep in mind, it's going to go through 0, 0, right? It does also go through 1, 1 and negative 1, 1, just like a parabola, but instead of 2, 4 being your next pieces, it'd be 2, 16. So that's why it goes up quicker. Okay. What we're going to do down here on the bottom part, they're going to give us an equation. Our job is to write the e. Rewind. They're going to give us a graph. Our job is to write the equation. Gosh, you guys knew what I meant. So, as we look at A, let's spend a few minutes talking about what are the pieces you see here. Okay, what can you identify? What kind of graph is this? What does it do? Where does it go? What are the pieces you can come up with here? Start with what shape is this? X to the third, yes? And here's the deal, you got 50-50 shot. It's either x to the third or x to the fourth today. So when we write our equation, I'm just going to kind of make a list here. I'm going to use my x to the third as my basic parent graph. Okay? What else is this graph doing? Compare it to the graph in the middle of your page. Does it look the same? Huh? Okay, it's going down instead of going up. What changed that? Be a reflection, yes? Think about those transformations in your list, okay? So this is going to be there's going to be a reflection in there. Reflection just means we're going to have to put a negative, right? We're going to put a negative out front. What else? And here's where I would say, look for your middle dot. Where did your middle dot start? And where did it end up? It moved where? 2, 4, which means it moved right 2 and up 4, yes? Okay. Did we get everything? The other thing that I would check, I'm trying to think if it happens or not. I don't know if it happens or not, but you should technically be checking for a stretch or a compression. Now, in a cubic graph, where are your other dots in relation to that center dot? They're over 1 and up and down 1, right? And that's what happened here. So no stretch or compression. Okay, so as we write this answer, I'm going to be official and start it off f of x equals. Keep in mind, f of x is the same thing as y. If you say y equals, I'm perfectly okay with that. Savas will probably already have the f of x equals, would be my guess. Okay, so you won't have to type that. Now, think about how we write this. How do we show a right 2? Huh? -2 in parentheses, yes? So I'm going to start by saying in parentheses, x minus 2. What type of graph is this? This is an x cubed. Now, that cubed, because we had a left to right movement, it goes outside the parentheses, yes? Okay. How do we show an up 4? Up 4 is a plus 4 outside the parentheses. And we didn't talk about which type of reflection this is. In reality, before you moved it, it could have been either. Okay, because it would have reflected first. It could have been either. It could have been a reflection over the x-axis or the y-axis in reality. But easiest for us is to take that negative and put it out front. Okay, so just like when you look up the reflection across the x, putting that negative out front of whatever's going on. Okay, and that would be the rule of thumb I would go with in this lesson. And did we get everything on there? We got x cubed, we reflected, we went right 2, we went up 4. There you go, guys. You've written an equation. Okay, questions on that? Okay, let's try B. Okay, give me the details. Okay, this is an x to the 4th graph. And how do I know it's an x to the 4th versus an x to the 2nd graph? because we're only going to have x to the fourth graphs today. Okay? Now, in reality, it doesn't go through the ordered pairs that would be over 2 up 4. That's the reality. But what's the easier thing for today? We're not going to have x squared graphs. They're going to be x to the fourth. Okay? Trying to make it easy. Okay, so it's x to the fourth. What else do we know? Okay, the vertex is at negative 1, 3. That vertex should have started at 0, 0, which means it moved left 1 and down 3. Any reflection? No, it's still just a right side up thing. Okay, so no reflection there. Any stretch or compression? No, from that vertex, that first set of pairs still goes, first set of ordered pairs still goes over 1 up 1. So no stretch or compression. Okay? Can you write this equation on your own this time? F of x equals. I would start with that left 1. Left 1 means x plus 1 in parentheses. When you have parentheses, that power is always going to go outside the parentheses. Down 3 goes outside the parentheses. If there was a reflection or a stretch or compression, it would go there in that gap I accidentally left. Looks like I left the gap because we need to put something in there. I don't know what I would put in there, though. Okay, let's keep moving. Okay, what shape do we see on C? This is an x to the fourth, right? What all happened with this x to the fourth graph? It's no longer right side up. It's upside down, so we know it's reflected. That vertex that should have started at 0, 0 is now where? What did you say it was? 1, 5. Is she right? They gave us kind of a weird setup here, didn't they? It's definitely at 1 because I have that marked. Over here, notice it counts 1, 2, 3, 4. So yes, that indeed would be 1, 5. So that is right 1, up 5. Okay, they're trying to play with our minds here. Let's decide if there's any vertical stretch or compression. I see a set of points. Do you guys see that same set of points with me? How far over and down are they? They're over how far? 2 boxes is over what? 1. So technically they're over 1 and down 1. They're trying to trick us, yes? Okay. It looks like there's some kind of compression going on, but that's just because they didn't count by ones on both axes. So in reality, if you look at points, it's over 1, down 1, so no stretch or compression. And honestly, I don't remember if you have stretch or compressions in homework. I really don't. You might not even have them, but I'm still going to address it just because we have to pay attention. Okay. F of x equals. Guess I'll just keep going the same order I have been. Left or right, I'm going to go right 1, so x minus 1. Remember, left and right are opposites. A power of x to the fourth always goes outside the parentheses if there are some. Up 5, plus 5, and did you get your negative in for a reflection? Okay. D. Are we getting the basics here? I don't think this one's too horribly difficult. I don't know. We've done a lot more difficult than this is what I would say, I guess. Okay, what graph is this? It's definitely an x to the third. Is it the right way or is it reflected? It's reflected, yes. Instead of going increasing, it's decreasing, so it's reflected again. And I use that center point. That center point moved where? Left 3 and down 1. And then are your next set of points over 1 and up and down 1? Looks like it. So there shouldn't be any stretch or compression. Okay. F of x equals left 3 is going to be x plus 3 in parentheses. Outside, my power is a 3. Down 1 is minus 1. Minus out front is your reflection. Guess you didn't even get a normal x to the third graph on here, did you? I reflected at both of them for you. Okay, one more. What shape is this? X to the fourth. I will say because of the way the graph's set up, it looks like x to the second for me, but it's not if you count. Okay, let's see. It's a right side up U, so no reflection. We normally start at 0, 0. Where did I move? 2, 6, yes. Use their labels on this case because, again, they're trying to trick us. We went right 2, up 6. I say they because this example came out of the book or the online book or something. In reality, who picked the example? I did. But still, they created the example. What about stretch or compression? They labeled a point for us, didn't they? How far is that point? It's over 1, up 1 if you compare the ordered pairs, isn't it? Okay, so over 1, up 1 means no stretch or compression. Okay? Can you write the equation on your own? Have you? Are you? Does yours match mine? In the parentheses, x minus 2, because we went right 2. The power on the parentheses is a 4 because this is an x to the fourth graph. Up 6, so plus 6 outside. And no reflection, stretch, or compression, so nothing in front of the parentheses. Okay? Okay, guys. You guys have some extra work time today. 3.7 is available. It will be listed as due tomorrow. A whole bunch of you need to go back and do 3.6 still. And so if you need any help on 3.6, now would be a good time to let me help you on 3.6. Okay, so I did update the grade book yesterday afternoon up through 3.6. Okay, so I don't know, 3.6 either got overlooked last week or it was really difficult. No one wanted to do it. I don't know. I have very few people that finished 3.6 last week. Okay.